Because
Alrighty. Hello, everyone. I'm Cole. I'm also the vice president. Today we'll be going over how to use Unity pretty much. So, if you haven't already, you should have installed Unity. If you click here, we're using the latest version. Typically, any version from until like 2017 should work. But if you do encounter problems, it's probably a version error. So once you open this up, we can click New Project, and you should be welcomed with this screen. Here you can see all the templates Unity has. So for this project, we'll use Universal 2D. If you want to look up more between different versions, so like the 2D built-in render pipeline, there's lots of resources online. It's a little out of the scope for this tutorial. So here you can change the project name. So tutorial, you can just call it 1 or something like that. And then you can also choose location and then click create project. And this will take quite a bit of time. So while that's working on that, you can go to Discord, and if you go to the meeting chat, I posted a link to the student orgs download place, I guess, and that's under the meetings chat. So click that. So then from here, if you look in the top right, you can click download. Once that's done, you can click there to show in folder. And I don't know where all of you have yours set up or how it works with Mac, so just navigate there. In Windows, you can right click and then extract all to unzip the file. Check back with Unity.
Yeah.
If the project has loaded, you should see something pretty similar to this. But from here, you can see how Unity projects are set up. So over here, we have the scene hierarchy. So here you have different scenes. By default, Unity gives you a sample scene with a camera, so where you look in the scene, along with just a global light, so that things aren't just all dark. And then down here, you have the file structure. So assets is typically where you'll work. Unity has a lot of built-in things within packages, so we just won't open that because that can get pretty complicated. But within assets, you can see all the files right here that are in there. So if we right-click, go to import new asset, should be just a little bit up from the middle, and then click on that. Should open up your file explorer, go to wherever you extracted the files that you downloaded, and then just select all of them and then click import. And then from there, that should be all the scripts and sprites and all the sound we need for this tutorial. We'll go over them in a little bit, but what I would like to do is start off by making a platform for our game. So if we right click in the scene hierarchy, go to 2D object, go over to sprites, you can select square. And that'll just create a nice little square for you right in the middle of the scene. We can rename this on the left side to platform. If you want to rename it again, you can just double click, and then you can see up here we have the scene view, and there's also a game view, which shows you what the camera sees in the scene. So if you select the main camera, you can actually go over to this transform component. This is the inspector window, and it shows you all the different classes associated with a game object. These things over here are called game objects, by the way. If you're familiar with object-oriented programming, these are just objects. If you're not, they're just nice little things that you can attach to game objects. So for the transform, you can adjust the X position. It's
so right click under the screen hierarchy and close the thing again.
right click, go to 2D object,
2D object, okay.
and then you can go to sprites. And then you can create any of those. For a platform, we're going to use a square. So, yep. But yes, back to transform. So you can see as I move the X position within the scene, you can see the camera box moving, and then in this lower right hand corner you can also see what the camera sees. So as the camera moves left, it looks like the square is moving right. As it moves right, it looks like the square is moving left. We can just click these three dots in the top right and click reset, and that'll reset the camera to the base position. Actually, you can just press Ctrl Z and it'll undo camera movements. We want a Z of -10, so make sure you have that. That basically just means wherever our plane is, we're moving the camera 10 units back so it can look at it. Otherwise, you're just face first into a bunch of sprites. So, from there, we can go to the platform and we can investigate more things with the transform. So if you want to rotate the square, you can go to Z and press, let's say, 45 degrees. Now the square is at a 45-degree angle. And then from there, you can also adjust the scale. So if you want the platform to be wider, you can adjust the X scale. So if we put 3, you have a nice wide platform. And then if you want to adjust the Y, you go like 0.75. Boom, it's a little bit squished down more. And then from there, to duplicate, or I should say, before that, let's go down here, and what you're going to want to add is a box collider 2D. Make sure you do the 2D version, not the 3D version. The 2D is for 2D games, and the 3D, or the normal one, is for 3D. So make sure you do box collider 2D. And then from there, you'll see a lot of options. We aren't really going to care about those too much. If we zoom in on our box, you can see if you adjust the offset of a box collider, you'll see a nice little green outline. That'll move around. Same with the Y. Right now we don't want to adjust that. So 0, 0, and then you can also adjust the size. We also do not want to adjust that quite yet, or at all for this project. Just some nice things to know about. And essentially, for those of you that don't know what a box collider is, within a bunch of colliders, you can check when they overlap. So you can have custom logic for that. For example, later in this example, we'll have some coins that you can pick up, and for that we need to check when two colliders are overlapping. but a collider is also essential for the next thing we're going to add, a rigid body 2D. And what this allows you to do is apply physics to a game object. So for the platforms, you can see this body type up here. There's dynamic, kinematic, and static. Dynamic and kinematic are for things that move, and then static is for just something that doesn't move, that stays in place. For this, since it's a platform, it's not going to move, so we can select static, and then that is all we need to do for the platform. And then if we scroll out a little bit, there's a few different ways you can duplicate objects in Unity. First one, if you press Control C and then Control V, just copy and paste, you'll see there's a duplicate object. That will work, but it can sometimes get a little bit messy once you have a scene full of similar objects. So what you can actually do is press Control Z twice to undo that. And then we can right click in the this assets area, go up to the top, press create, and then create folder. And that will create a new folder within your file system. And then here we can just call this prefabs. He knows what's up. So yeah, this is pretty common for most Unity projects to have a folder called prefabs. You can double click to enter it, and then on the left side here in the object hierarchy or the scene hierarchy, you can click the platform and just drag it right into the prefabs folder. And you'll notice that the platform object turned blue within the hierarchy. That means it's a prefab. And another thing you can do with prefabs is just click it within the file explorer and then drag it into the scene. And that creates a duplicate object, and those objects will also be linked. So I'll go over more of that in a little bit. But for now, you just click and drag 3 objects in, and if you're a perfectionist like me, you'll notice that these are not straight. And if you look at the transform, you can see an X of -7 point some random numbers. And then in order to fix that, you could manually adjust all the positions, or if you want it to be super easy, you can notice this nice little grayed out box that says toggle grid snapping. We're going to want to turn that on, but before that, we have to ensure that this rotation is set to global. And then we are going to want to click the move tool. There's a bunch of tools here. They're pretty handy for navigating around. The move tool allows you to move game objects. So without grid snapping, if we just move them, it's nice and smooth. But if we activate grid snapping, then it moves in little chunks. So we can move the Y and then move the X, and you'll notice the position is set to intervals of 1. The original one is at 0, 0. This one needs to be moved. So if we move it there and there. And then all our platforms should be nice and grid aligned. And then we can just drag one more platform. This will be our base platform. And this one, let's make this one 20 wide. So you'll notice that even though this one's different than the other ones and they're all the same prefab, they're all blue in the hierarchy. If we double click on the platform prefab within the file explorer, it'll open this blue scene where it's just this platform. And from within here, we can adjust all the prefabs. So we'll say, oh, this platform's a little too thick. We can drop down the Y scale down to 0.5. And then if we go back here to the scene, just click there to scenes and it'll bring you back here. You'll notice all the platforms have a Y scale of 0.5 now. So that the prefab makes it super easy to adjust all things across a prefab. So you can adjust specific values, like the color of the platform, just simple things like that. And from here, if you click play,
Okay.
should take a little while to load, but then it swaps to game view, and this is what your player will see during the game. Yep. You'll notice that if you press the arrow keys or anything, nothing will happen, and that's because we haven't implemented any logic for that. And for that part, you'll want to click play again, and that'll exit you from the game view. And then from there, we can go back to the assets root folder where we imported all our assets, and we're going to want to make another folder. So if we go over here to create folder, we can call this one sprites. We're going to want to move the Among Us image and Mega Man into that folder. So just control click on those, click and drag them over to sprites, and that'll set up our sprites folder. And then within there, you can take Mega Man and you can drag him into our scene. You'll notice he's ridiculously large, so we'll probably want to scale him down. The numbers I'm using are 0.1 for the X and Y. I would recommend you guys do the same. There's some code that relies on his scale being right, so X and Y of 0.1. And then from there, in order to interact with the platforms, we're going to need a collider. So just for fun, we're going to do a circle collider. Circle collider 2D. Make sure it says 2D. If you use stuff that doesn't say 2D in 2D, things won't work and you'll smash your head into your keyboard for hours on end until you find a Stack Overflow post that describes how to solve it. Don't ask me how I know. And then with that, we're going to want a rigid body 2D. And that should be our player setup. For the rigid body 2D, this time we're going to want dynamic because it's moving. And then here you can see a lot of settings, so like mass. When you get into collisions between two dynamic bodies, mass is going to play a factor in that. We don't have to worry about that for this tutorial. Linear drag, angular drag, don't worry about those yet. Gravity scale, so now that this object is moving, we're going to want it to be affected by gravity. So right now, gravity is just set to 1. You can adjust that for however you want it to. 1 is probably what I'd recommend right now. And then some more settings that there's some good Unity articles online you can read about, and those will give you more information about those. And then we go back to the assets root folder. You'll see these hashtag marks on these files. That means they're a C# script. So in order to better filter those out, we'll create another folder. We can call this one scripts. And then again, just click and drag those into your scripts folder. And then in order to attach those scripts to our player, well, it'll reload for a second since you moved the location of scripts. Needs to adjust some things that it compiles. So then, let's say we want our player to move. We can go to this player movement script, click on it, and then drag it over here to the add component part. You should see if it's a red circle with the cross in it, that means you can't drag it there. Just scroll down a little bit and until you see the little box with the plus on it. You can release, and then boom, now your player object has this player movement script attached to it. In order for this to work, we're gonna need to click and drag some components. So if we go up here, click on the left side, you can compress these down a little bit. And then you can click and drag the transform. Click it to the, or drag it to the one that says transform. And then for sprite, it says there's no sprite renderer, so we need to go to the sprite renderer and click and drag that to there. And then from there, you can adjust the movement speed. We'll go 5, and then the jump speed to we'll go 500. And then we can click play. And what you should see is your player moving left and right when you use the arrow keys. You'll notice when you press the up button that jumping does not work. I'll dive into the code a little bit to explain why that is. But right now you should have your player moving left and right, and the sprite should flip as well with that. So from here, stop playing. Actually, you know what? This will be a good learning point. So if you press play, you can move side to side, and then if you go over to your hierarchy and click on Mega Man, and go over here and you can adjust his movement speed. So if we want, let's say 50 instead of 5, you move left and right, you'll notice Mega Man is freakishly fast. But you'll also notice if you stop playing, his movement speed goes back to 5. A lot of mistakes people will make is they're playing their game, they're testing out things, they're adjusting values, everything feels great, and then they press play again, they quit playing, and all their finely tuned values just got thrown away. So that's a pretty common mistake for people to make, even advanced people, so just make sure you aren't playing while you're adjusting the values too much.
Or if you do, just save it as a preset and load it later.
Yep, yep. So then from here, we will want to add some coins. Oh, jump. Yep, my bad. So yeah, if you double click on the player movement script within the file explorer, it should automatically open up Visual Studio if you have it installed. A big part of programming or game development is programming, so I'll run you through what these different lines are doing. So within here, we have some default imports. That basically just makes certain functionalities available. You typically don't have to look at these too much. Unity kind of just adds them for you, especially if you use Visual Studio. That's really handy. And then within here, we have a class called Player Movement. That should auto-generate for you as well. And then extends a mono behavior class. If that doesn't make any sense to you, don't worry about it. Unity does that for you when you create a new script. And then from here, we have variables for the class. So serialized field, you'll notice that above most of these variables. And what that does is it makes it available to view in the editor. So all these classes, or all these fields are visible within the editor. Anyway, if we go back to our scene, click on our Mega Man, you'll see we have the movement speed, jump speed, is grounded, player transform, and sprite. Within Visual Studio, if we take away the actually, never mind, I won't do that. You don't edit anything. But if you take away serialized field, those will disappear from the editor and you won't be able to adjust them. Right now, I have all of them visible since it makes explaining things easier. It's also pretty handy for debugging without having to print a bunch of stuff. We'll go over more about debugging in a little bit. But, so we have one for our movement speed, our jump speed, is grounded, checks if you are on a piece of ground. So when you jump in the air, you're not going to be on the ground, so is grounded will be false, which means you can't jump again. But if it's true, then you can jump. Down here, you'll notice there's a singular function called update. Update is a function that Unity automatically gives you. Basically what that means, for those of you not familiar with functions, is that this will automatically be called for every class once every frame. So this is how you can update things like movement, you can keep a timer, you can update score using this. Essentially, you can do a lot of things. And then down here, you'll notice 3 if statements. If you aren't familiar with if statements, this is the basic syntax. You write if, pair of parentheses, and then if whatever inside evaluates to true, then the code within the curly braces is executed. If not, it jumps out and doesn't execute that code and just continues on. So for this first one, if you do /E in C# that's a comment, which means
It's the same in Java and JavaScript.
yep,
as well.
it's the same in a lot of languages,
I
but
think that's how you did comments in Python.
basically,
But I'd have to suffer using Python again just to see that.
yeah.
That's
Basically, anything you write after this will not be executed. You can see because it's the nice program or code color green. I don't know what that specific hue is, but that'll do a single line. If you want to do double lined, you'll have to do the slash and then the asterisk, and then anything you put in between there will also be a comment. But this is left movement, and essentially how Unity does that, they have a field just available globally called input, and then .getKey gets you a specific key, and then the key code we're looking for is left. So that means, or the left arrow. That means whenever you press the left arrow, this if block will execute, and the inside will be executed as well. Within that code block, you'll notice we have a transform.position that is just given to you as well. Any game object has a transform available, so if you, in order to adjust the transform, again, if we go back here, go back to the transform, you'll notice it has a position, rotation, and scale. Right now, we just want to adjust where the player is positionally. So if we do transform.position, we get the position, and then we want to add to the position. We want to go left, so you can choose vector 3 left. That's just shorthand for 1 in the, or -1 in the x direction, and 0 in the y, and 0 in the z. Vector 3s, if you aren't familiar with vectors, just 3 values, typically coordinates. so X, Y, and Z. So -1 in the X position will bring us left, and then we want to multiply by our movement speed, so we can go a little bit faster or a little bit slower. And then this last thing, time.delta time. I don't want to dive too deep into this, but essentially this just makes it so that your character moves independent of frame rate. Basically, it's just the time between frames, so that if you don't have that, your speed will heavily depend on frame rate. And then here, we just have a nice little Boolean variable called sprite flip X. So when we clicked and dragged our sprite renderer in, that connected our sprite renderer to this variable. And then within that variable, Unity has a built-in thing called flip X. So when we move left, we want to have the sprite be flipped. And then if we go down one more, get key code right arrow, that, as you might guess, is essentially the same thing with the right arrow key, and the only difference is the vector 3 right, shorthand for 1 in the X, 0 in the Y, 0 in the Z, and then you set the sprite flip to false since you're moving right. And then this last one is the up arrow. And you'll notice instead of get key, it's get key down. Essentially what that means is instead of every loop where it's being pressed, the first time you press it, this function will run, and then it won't run again until you press the key down again. So from there, we have the isGrounded Boolean, and this does array cast, which you don't have to understand too much, but if we go into a little paint.net, I created this fancy diagram for you. It's Thank you. Yes. So essentially, what array is a single point and then a direction. So most people just have it at the origin, and then you can just have an X, Y, and a Z, and then that will point a certain direction, if that makes sense. So from there, we can investigate this a little bit more. So from here, this is another way to get your transform. Instead of just having it globally, you can create the field here, the serialized field, and then you can click and drag it from where we did in the beginning. And then from there, this function, if you kind of scroll over it in Visual Studio, it'll have this nice little box pop up, and it'll tell you the parameters it takes. So here it takes a vector2 origin, vector2 direction, a float distance, and then a layer mask. And that all sounds pretty complicated, but basically you just need to feed in your transform position, the direction you want it to shoot, and since we want to check for ground beneath us, we say vector3 down. The length of the array, this is just an arbitrary value I coded, 0.55f. You can adjust that, but this basically just allows us to check right below the ground for us. And then if you go here, one arrow layer mask, name to layer, that's basically just checking for any collider within the layer ground. And you're probably pretty confused because we haven't added a ground layer yet, and that'll be why we can't jump. But essentially, if you are close to the ground, if the ray hits ground, then isGrounded is true. So then if you hit the ground, we're going to get the component rigid body 2D. This is how you can access components from a game object without having to serialize a field. So if you don't want to click and drag you can just do get component and then those less than and greater than. They're also called arrow brackets, I believe. And then you can just specify the component you want. So rigid body 2D, little function call, and then dot add force. That will add a force to your object. So gravity, that's a force. You accelerate downward because force is being constantly applied. But for our jump, we just want an initial force to push us up, and then gravity will eventually overpower us and pull us down. So the force, we're going to want vector 3 up, and then times our jump speed. Jump speed should probably be called jump force instead, but whatever works. And then we want to set is grounded to false because we just jumped off the ground and we don't want to jump again. So from there, we know we need to add a layer called ground. So if we go back to the Unity editor, this part you'll have to do. Since we want all our platforms, we can go to the platform prefab, double click on it. If you have the blue background, that means you're editing the platform. Go up to the top right, you'll see layer, and that says default. We do not want that. So we go to add layer, user layer 6, and then you can add ground. Here, you want to make sure that ground is capitalized. Spelling is important for this part, but here specifically, because it says ground with a capital G, that's what we're looking for. Make sure you have capital G there. And once that's added, you can click on platform again. You'll notice that our layer still says default. We just created the layer, we didn't apply it. So go to default and then select ground. And now your platform should have ground attached to it. Jump back, press play. You'll notice you should be able to jump now. While you're moving, you'll notice if your player jumps up and hits a platform, they'll start rolling weird. That's part of Unity's built-in physics, which you probably don't want for your platformer.
Yeah.
So if we click on Mega Man, we can adjust that setting in Rigid Body 2D.
Yeah.
If you go down to constraints within Rigid Body 2D, you'll notice there's a freeze position option. So if we freeze rotation on the Z axis, check that little box, then press play.
It's still, no matter what, it'll still be weird. Because it's.
You'll notice if we jump up, our player will just kind of slide off the side instead of actually falling off the side. And if you don't want them to slide off the side, just change it to a box collider. We just used a circle collider since we wanted to give you some exposure to different types of colliders. From there, unclick play, you can click right click, and we're gonna try and add some coins now. So if we go to sprites, let's go, let's go to prefabs, or no, not prefabs, sprites. Sprites, click Amogus, click and drag that in. We can make Amogus coins. So that guy's a little big. We should have, yeah. Oh yeah, we should have done the neck snapping one. But next time. Let's make this 0.2 on the X, and I'd imagine 0.2 on the Y. Got a nice little Amogus guy. If we go over to the right side, click Add Component, and then type in Capsule Collider 2D. Make sure it says 2D. Again, if it doesn't have 2D, things will break and you won't have a good time. So Capsule Collider 2D. I believe this should be good. You'll notice the capsule fits our Amogus guy. If you want to adjust that a little bit, like on the X, you can narrow that up however you want. But this will allow us to detect collisions with our Amogus guy. And for that, we want to click is trigger. That will allow us to use a certain function in the code. I'll go over that in a little bit, but if we click add component, we can also search for the coin script. That's one of the scripts we added. So if you click that from there, you'll see it added our coin script guy. And then from there, you can just click on the, let's see, curious. Yeah, okay, so click on the Amogus, drag that to me the coin. You'll notice that's a game object, so we want to select the game object and drag it over there. The collider, grab the collider, click and drag that there. And then sound maker, we haven't added that yet. So from there, you can click and drag our Amogus guy into the prefabs. Double click on that, and you'll notice once you click into it, the transform is a little bit different. So you want to change that to a 0, that to a 0, and then if we zoom out a little bit, you'll see he's back to the origin. Go back to scenes, he's right there, and then we can click and drag 2 more into the scene, 1 on each platform. And you'll notice we need a sound maker. So for that, what we did is right click on the hierarchy panel, click create empty. This will create an empty game object with no sprite, just a single transform, and we can call this audio player. And then we can go over here, click reset on the transform. After clicking the three little stacked circles, that'll reset the transform. Doesn't really matter where it is, and then from here we can go audio source right there. So add the audio source, and you'll notice it needs an audio clip. So go back to our assets root folder, create a new folder, and call this audio. So you can click the coin noise, bring it into audio, double click in there, and then just click and drag that into the audio clips. Now we have an audio player for our coin noise, and then within the Amogus, we can actually shift click all of them at one time, and then you can see within the editor, you can see the similarities that they have as well as their differences. So their position, their Y is the same, but their X is different, so it has that little line there. But what that allows us to do is click and drag the audio player into the sound maker. And that is how you can link different objects together through the editor. Since the audio player has the audio source, now all the Amogus coins have access to the sound maker from that. So from there, if we click play, when we try and collect the coin, you'll notice that is because we are also missing a script. We can see that when we try and look into the Amogus coin script. We'll walk through that a little bit. Here you can see the fields that we have available. So the collider, the coin or the game object, and then the audio source. And then here there's just a nice little function that Unity gives us as well. you'll remember when we clicked is trigger on the collider for the coin, that gives us access to this function, and essentially whenever another collider, 2D collider, interacts with it, this function will be called, and from there we'll do a debug.log, and that'll say test. And that's one way you can debug your code. So if we go back to the Unity editor, go to console, you'll see when we hit the coin, it sent out this message called test. And through code, you can send certain variables through that. You can debug.log certain messages. That's a pretty common way of debugging your code. And then from there, we get the audio source sound maker, and we press play, and that'll play a noise. And then we have player score. Well, we haven't added that yet, but when we get the other component, we get their player score component, and then if they have the component, you update it, and then destroy the coin. So, what that means is we need to add a player score component to our player. Go over to our player, click and drag player score, boom, that script is added. Then you'll notice it says it needs a Text Mesh Pro UGUI. Don't ask me what the UGUI stands for, but what that means is we need to add some UI. So if we scroll out a little bit, go to the right side, or to the left side, I should say, right click, scroll down to UI, and then from UI, you'll want to select Text Mesh Pro, and then click yes, and then this importer will pop up. You'll want to click Import TMP Essentials. That'll take a second to load, and then you can just exit out of that. You don't need anything else. But if you scroll out even more, you'll see how Unity does some of their UI. You'll see big ol' rectangle, and that's what your screen sees for UI. You'll notice this little text thing, along with in the editor, it has added a canvas and a text and event system. Essentially, what you'll need to do is move this up to the top left, and then within the inspector, you'll see it has a bunch of these weird things. You don't have to worry about that too much. There's a Text Mesh Pro text UI. You can adjust that and say score, and now your text will say score. We'll change that in the code so it doesn't actually matter what it says right now, but if you click here, you'll see this little box thing updated, and this will anchor UI to the screen. So let's say we want it in the top left corner. We can click top left, and we can adjust the position 0, 0, 50, 100. Looks like 100, and then negative 25. That will get you to your top left corner. If you don't have it like that, so that will anchor it to the top left. If it's not anchored to the top left, let's say we anchor it to the right, you'll see it's in the top left right now, and when you click the game, it looks like it's in the top left. But once you change resolutions, make your game screen big, it gets to the middle, because that's the distance to the right side when it's small. If you want to go full screen with game, you can just double click it, and then double clicking it will shrink it down again. So having your UI elements properly anchored is really important. So we want it in the top left. And then from there, you can just rename it in the hierarchy to something nice like UI we can go score text. It doesn't really matter what it's called. It just helps you keep track of stuff within your scene. But then if we scroll back down to little Mega Man, you'll see within the player score script, there's a score text. You can click on that in the hierarchy and link it there. Now, everything, I believe, should be working. You can press play. That coin gets destroyed. I think we have volume. Okay. Yeah. Again, we probably should have done like an emergency meeting or like a Among Us next snap, but next time.
I like to visualize it. The visual.
And then you'll notice when I started the game, it played the noise immediately. If we want to change that, we can go into the audio player, go over to the audio source, and then there's a little checkbox that says play on awake. We do not want that. Unclick that and it should work. And that's essentially the whole project setup. I will go over some more of the scripts. So here, we get the player score component once the coin is collided with, and then we call a function on the score component called update score. So if we go over to, so if we open up the player score script, you'll notice we have the UI, and then a private int called score that nothing else can see.
My score isn't working.
Within start, Ethan should be able to help you in a little bit, or yeah, Wyatt can. Within start, we call this function called update text. Start is actually a function that Unity also gives you by default. Essentially, at the very beginning, start is called once, and then never again. So once an object is created, that plays, or this is called. You don't have to worry about anything else other than that. And then down here we have a little update text function. And that basically takes the UI text and then sets it equal to score and the private variable that we define here. So right away, when it starts, it'll set that text to score 0. And then whenever the update score function is called, then the score will be incremented by the amount you send, and then it'll update the text. So if we go to the coin and we want, let's say, the coin to be worth 10 points instead, we just adjust that amount right there. So now whenever the coin is collected, score will be updated 10, and then this function destroys game objects. So here we pass it the coin itself, and then the coin will be destroyed. What you don't want to do is include code after, because sometimes what can happen is the coin will call the destroy function, and then before it can get to this line, the coin has already been destroyed. So you want to make sure that's the last thing you do. So now if we save that and go back to here, it'll compile the scripts, and then give it a second, press play. Now that is the whole tutorial. So, anyone have questions? Ethan helped design it too, so.
Yeah, Ethan.